Okay, finally, we're going to use these radicals in order to solve equations. So I'm going to show you this equation two different ways because we can solve it with a radical or with a rational exponent. So for our first one, we got x cubed equals 64. We've already got the x with its power by itself on one side of the equation. So my next move would be to undo the exponent. One way to do that would be to take an appropriate root of both sides of the equation. Now the root that would undo a third power would have to be a third root. They'd have to have the same index. And if I do it to one side of the equation, then of course I have to do it to the other because that's how algebra works. So on the left, the third root and the third power cancel each other out, which just leaves you with an x. On the right, we've got the third root of 64. So you would evaluate that like we were doing before. So what times itself 3 times makes 64? That would be a 4. Okay, the second way that I could do the same problem, let's say x cubed equals 64, is I could raise both sides of this equation to a power that would cause that 3 to become a 1. So that power would be whatever the reciprocal of 3 is. So I could raise it to the 1/3 power. So x to the third to the 1/3, the rule there is you multiply those powers together, so you would get just x. On the right, I'd have 64 to the 1/3 power, which I would probably then go ahead and rewrite as a third root. And then I would just evaluate. The third root of 64 is 4. So either way, I get the same result. For my next example, I've got 3x squared equals 48. My variable with its power is not alone yet. There is a coefficient there with it. So the first thing I want to do is get rid of that coefficient. Now 3x squared means 3 times x squared. So to undo that multiplication, I would have to divide by 3. So that would give me on the left just x squared. And on the right, 48 divided by 3 is 16. All right, next I could solve the equation by taking roots. So the appropriate root to get rid of a second power would be a square root. So I'm going to go ahead and write square root on both sides. Now, whenever you're taking a root, a radical, to solve an equation, if the index number of your radical is even, then when you take that root on both sides, you have to use a plus or minus. So in this case, since it's a square root, the index is 2, which is of course an even number. So there's going to have to be a plus or minus there. So this will be on the left, the square root of x squared is x. On the right, I'm going to have plus or minus. The square root of 16 is 4. So this would give me plus or minus 4. So this one has 2 answers. For my final example here, I have to get the x with its power alone before I do anything else. So I've got x to the 6th minus 15 equals 75. So my first step would be to get rid of that minus 15. So I do that by adding 15 to both sides of the equation. That would give me just x to the 6th power on the left. On the right, 75 plus 15 is 90. Then I need to get rid of that 6th power. So I could do that with a radical. So my radical would be a 6th root. Again, my index number on this one is even. So just like on that last one, if I'm using a root on both sides of my equation, I'm going to have to put in a plus or minus. So now on the left, I've got the 6th root of x to the 6th. So that root and that power will cancel each other out. That gives me just x. On the right, I'm going to have plus or minus, and then I need something times itself 6 times. That would give me 90. Now, just with a preliminary little check there, I could find that there's no whole number that's going to give me 90 when I multiply it times itself 6 times. So I'm just going to leave it as the 6th root of 90 for my answer. So I've got plus or minus the 6th root of 90, which means that that's actually 2 answers for this one, not just one. All right, now you answer the rest of the questions on the Google form, and then check yourself and see how you did. If you have questions about it, go back and maybe watch the video again. If you feel like you've got it, then go ahead and move on to the practice.